Hi, Justin. I need to apologize first about my voice. I contracted some sort of stomach bug today that is currently destroying me. So I will try to speak clearly enough for you to understand. So let's start with, well, since you're not here, I can't ask you, but let's start with part A, f of 4, 2. So what that means is if you're thinking of f as, let's just say f is height above sea level in feet or something. So if you're at location 4, 2, you're about right there. So since this is 1 foot above sea level and you're pretty close to that contour line, and since you're between 0 and 1, right here I would estimate f of 4, 2 to be about zero point 0.9 or something. But there's a range of correct answers. You could say anything between zero point 0.5 and 1, and I would take it, simply because your height is probably somewhere between 0 and 1. Okay, so now let's move on to the derivative questions. Um, okay, so now we're here at 4, 6. And to be precise, we're at 4, 6, and then about a height of negative 2.5. Because this contour line here is negative 2, and this contour line here is negative 3. So when you're standing right here, you are about 2.5 feet below sea level. So imagine yourself standing right here. Okay, you're at 4, 6 and the XY plane, and if you like, you're 2.5 feet below sea level. Imagine just looking in different directions. You could look due north if you want. You could look due east, due south. You could look southeast. You could look 20 degrees southeast, so kind of like this. And sorry, I can't actually draw these vectors on here because I lack the technology, but the mouse is drawing a vector direction, right? So due east means the vector I pointing this way. Due west is the vector negative I in the negative x direction. And you could go like 10 degrees, what is this, southwest. So my point is that there are many, many directions in which you can look. There are infinitely many, in fact. And so if you think about what a derivative is, what it's trying to tell you, one of the things it is trying to tell you is the rate of change of a function, in this case f. So if this is, height above sea level, any derivative is trying to tell you something about how sea level height changes. Just like in Calc 1, the tangent line is an approximation of the curve. So when you start computing derivatives, you're basically asking yourself approximately how much does the function change? Because again, it's a rate of change of a function f. So let's plop ourselves down right here. Fx of 4s. What does that literally mean? What it's trying to tell you is how much the function changes if you take a single step in the x direction, or if you like, in the I direction. So since this is 4 and this is 5, you're talking about taking a step from right here to about right there. Whoop. Okay, so taking a single step in the x direction. So suppose I ask you, okay, you've taken a step in the x direction, by how much has the function changed? You would say, well, I used to be at negative 2.5, right? So 2.5 feet below sea level. And when I'm right here, I'm about midway between negative 2 and negative 1, which means I'm about now negative 1.5 feet height, so 1.5 feet below sea level. So if you take one step in the x direction, and the step must be length 1, okay, we're dealing with unit steps, unit vector steps. If you take a single step to the right by 1, by how much has the function changed? That is what fx4s is trying to estimate for you. It's trying to give you how much the function changes when you step in the x direction. So after all of that, I would accept an answer of something around 1, because you moved from negative 2.5 to about negative 1.5. So again, there's a margin of error there because these are all estimates, but about negative 1 is what you expect the function to change by. And so let's now move on to the next one, 1 over root 2, 1 over root 2. That's just a vector that's pointing due northeast. So 1 over root 2, 1 over root 2 is like this. And again, you're taking a step of length 1. So you're going from negative 2.5 to about 3 feet below sea level, depending on how you draw your vector here, right? Depending on how you draw this guy starting at 4, 6. So if you go due northeast, you have actually decreased your height by about a half, because you were at this height here of negative 2.5, and now you're about on the negative 3 contour line. So the function has changed by about negative a half. And to do the rest of these, you just keep playing the same game. So u equals negative j, that's pointing in the southerly direction. So now you take a single y step, but down. So if instead of negative j, you were doing j, that would be a positive y step, which is the same thing as fy 4, 6. Okay, so fx and fy are just two particular directions, a due north direction and a due east direction. But of course, there are many other directions. In particular, there's a south direction. And notice if you take a single y step south, you are about right here. And once again, your height changed from about negative 2.5 to about negative 1.5-ish. You know, it's all estimates. So the directional derivative now is about 1, because again, you've increased the function by 1. So all these things, again, are trying to give you estimates of how the function changes in a particular direction. So it's like any derivative, trying to give you a rate of change of a function. So let's end with maybe this 1 over root 2, negative 1 over root 2. So that's pointing 1 over root 2 is this way, and then you got to go negative 1 over root 2 down. So you're about right there if you take a single step in the southeast direction. So you have increased your height from negative 2.5 to negative 1. So the rate of change, or the function, changed by about 1.5. So f would be 1.5. So the big picture here is, take this point, draw a circle of radius 1 about it. So something like this. That circle, every single point in that circle gives you a direction you could be looking, right? And so all I'm doing with these vectors is saying, look this way, and then tell me how much the height changes when you walk to the edge of that circle. So if you take one step up, you're at the top of the circle, one step down, bottom of the circle, one step southeast, the southeast side, you know, whatever, southeast corner of the circle. I don't know if that makes sense. But anyway, that's what's going on. The final question here is, in what direction is gradient f(4,6) pointing? So the important thing to remember is that a gradient is a vector. So when you plug in x and y values into the gradient, it is a vector, and the gradient vector always points in the direction of most steepness. So if I'm right here, it looks like the gradient points basically southeast. That's the direction of greatest steepness. So in class, what I pointed out, without justification, but I pointed out that the gradient vector is always perpendicular to the corresponding level curve. So since this point is basically on this curve, well, this curve here, you could ask yourself, well, what vector is perpendicular to this? And you have two choices. Basically, a southeast one is perpendicular and a northwest one. But since the gradient always points in the direction of greater steepness, if you have a choice between going positive or negative, you go positive. So that's a way you can always estimate in what direction the gradient is pointing. Just ask yourself, okay, if I'm standing right here, what's the steepest step I could make? And in this case, you know, going up is certainly not the steepest, and I mean positive steepest, because here you're just going negative anyway, okay? But if you go about southeast, you're doing the best you can in terms of increasing the height of the function when taking a step of length 1. So on your exam for part H, you could literally write a vector that points in the southeast direction. So just draw like this, or you could draw, you know, the vector on here, right? It's pointing perpendicular to the level curve in the positive direction. Okay, so I hope